Okay, good morning, everybody, or good afternoon, or good evening, whenever you're watching this. Welcome to video number 3. And uh, the first thing we will do is go over the homework. And again, I want to stress that we are going to start getting more and more into proofs, especially after today. They're important. Deductive logic is going to help you in all of your classes, not just in geometry. Deductive logic is the way to approach things in all subject matters, being able to take statements and build on those statements until you can make a very valid conclusion. Alrighty, on page 62 was your first set of homework problems, and we defined what it meant for two lines, rays, or segments to be perpendicular. Never write the word perpendicular. We're going to use that little symbol. That means perpendicular. And two lines, rays, or segments are perpendicular if they intersect, forming right angles. Since that's a definition, you can turn it around. If two lines, rays, or segments intersect at right angles, you can say they're perpendicular. And whenever you have this, a figure, and you've got that little box at the corner, that means that is a right angle. Since it's a right angle, that means this line segment and this are perpendicular because they intersect at right angles. Okay? Remember, all definitions are reversible. Not necessarily theorems, however, but definitions are always reversible. Some theorems that we will talk about are going to be able to be turned around, some are not. All right, problem number 2 on page 64. It said, in each of the following figures, name the angles that can be, they didn't ask you to do the actual proof. They said which could be proved to be a right angle. And that first figure looked like this, and they told you that this line segment and that line segment were perpendicular, MJKL. So since MJ is perpendicular to that, I know that angle MJK is a right angle. And that's the only figure in this, or the only angle in this figure that you can definitely say is a right angle, because perpendiculars intersect at right angles. They form a right angle. So that's number 2A. 2B, or not 2B? That is the question. You were given a figure that looked like this, NRP and Q, and they said that in this figure, RO is in fact perpendicular to PN. RO is perpendicular to PN. Therefore, there are two angles in this figure that I can say are right angles. Angle NOR, or angle RON, and angle POR, or ROP. Those two angles are right angles because lines, rays, or segments that are perpendicular intersect, forming right angles. Therefore, I know for a fact that those are the only two angles in this figure that I know are right angles. Please don't say, well, angle NRP sure looks like a right angle. Doesn't matter what it looks like. Remember, a figure is only a visual aid. It does not have to be accurate. So those are the only two angles in this figure that I know for a fact are right angles. And if you wanted to, you could have also done this. Call that angle 1 and that angle 2. And say angle 1, angle 2 are right angles. Again, sometimes numbering it makes it a whole lot easier to visualize. On number 1C, you were given a circle, and you were told that OT is perpendicular to SW. Again, you were told OT is not. All right, when you see that type of notation where they have a slash drawn through something like that, or like that, or with the congruent symbol, and you have a slash, that slash drawn through it means is not. So they're telling you here, OT is not perpendicular to SW. Since OT is not perpendicular to SW, in this figure, I cannot say that any angles are right angles. Since again, if OT is not perpendicular to SW, that means they do not intersect at right angles. They do not intersect forming right angles. So in this particular problem, I cannot say that any angles are right angles. I don't know. They may be. Well, actually, in this case, they are not. Since they're telling you that OT and SW are not perpendicular, then you know for a fact that they do not intersect at right angles. So in this figure, there are no right angles. I hope that makes sense. Any questions? Run the tape back. Okay, number 8. Number 8. By the way, I bought a camouflage pencil the other day, and I put it down, and now I can't find it. Think about it. Number 8. They gave you, in number 8, this figure. MRPO. And they told you in number 8 that angle MOR is 3x plus 7 degrees. And they told you that angle ROP is 4x minus 1 degrees. And they also told you that MO is perpendicular to OP. So I know for a fact that has to be a right angle. Two lines, rays, or segments that intersect at right angles or intersect perpendicularly form right angles. Therefore, if I add these two angles together, they have to add up to 90. So you get an algebraic equation, a fairly simple one. 3x plus 7 plus 4x minus 1 has to equal 90. Simple algebra. 3x plus 4x is 7x. 7x minus 1 is plus 6. So 7x is equal to 84. Subtract 6, divide by 7, and x is equal to 12. Don't stop there. They didn't ask you for what x was. The problem asked you which angle is larger, angle MOR or angle ROP. Well, just take x equals 12 and plug it back in. 4 times 12 is 48 minus 1 equals 47. Since this is 90, that makes this equal to 43. So angle ROP is bigger than angle MOR. This is 47 degrees. That's 43 degrees. That was the answer that they were looking for. Again, on a test, if you stop here, that is absolutely correct. X is 12, but remember, that is not the actual question that they asked. They asked you which of the two angles is bigger. So you take that value that you solved for, plug it back in, and the two angles end up being 47 and 43. Therefore, 47 is bigger than 43. Okay. We then we defined complementary and supplementary angles. And again, don't ever write them out. Don't write the word complementary or supplementary, just abbreviate it. COMP, draw the angle, put the little s. Again, little s in the vertex there, it means it's plural. Complementary angles. Two angles whose sum is 90 degrees. Supplementary angles. Two angles whose sum is exactly 180. Again, If I gave you three angles, 10, 20, and 60, well, 10 plus 20 plus 60 adds up to 90. But they're not called complementary angles because there's three of them. Two angles whose sum is 90 are called complementary angles. Two angles whose sum is 180 are called supplementary angles. Two. Okay? And we talked a little bit more about that in class. We are not going to ever talk about 0 and 90 as being complementary because we're not going to talk about 0-degree angles really in geometry. We will talk a little bit about it. We are going to do a section on trig, but even there we're not going to talk about 0 angles. You're going to Algebra 2, you're going to do a whole bunch of trigonometry, and you can talk about any angle trigonometrically speaking. You can talk about an infinitely large angle, an infinitely negative angle. You can talk about any angle trigonometrically. Geometrically, we're never going to talk about 0 or negative angles. And other than a circle, which has 360 degrees in it, a majority of our angles are going to be less than 360 also. Likewise, we do not talk about 0 and 180 as being supplementary. We also said in order for an angle to have a complement, any angle that is an acute angle will have a complement. As a matter of fact, the only kind of angles that can have complements are acute angles, and their complements will also be acute. 30 and 60, 10 and 80, 45 and 45. Those are acute angles, and their complements are also acute. Supplementary angles. There's only two cases where you can get supplementary angles. One is acute, the other is obtuse, 30 and 150. Or both are 90. 90 and 90 are in fact supplementary angles, and they're equal. Other than that, anytime you have supplementary angles, one of them has to be acute, the other will be obtuse, 30 and 150. 10 and 170, etc. So on page 69, number first one was number 5. It said one of two complementary angles is twice the other. Find the measure of the angles. One of two complementary angles. That means, again, you can do this in one variable, you can do it in two. I would recommend always, if you can, do it in one variable. If I say let x be the first angle, then the complement will be 90 minus x. And it said one of two complementary angles is twice the other. So again, I can pick one. It doesn't matter which one, and the other one it's twice the other one. That means I could say 90 minus x is equal to twice that, or I could say x is equal to twice that. And there's your equation. So let's do it. It doesn't matter which way. This angle, x, is equal to twice the other. So you get x is equal to, use the distributive law, 2 times everything inside is 180 minus 2x. Add the 2x to both sides, 3x equals 180. X therefore equals 60. So the angles are 60 and 30. It said one of two complementary angles is twice the other. Find the measure of the angles. They're 30 and 60. And again, you could have done this in two variables. I recommend you do it in one. And once you've got the two angles defined in terms of the same letter, it said one is twice the other. So I could have said x is twice that. I also could have said this is twice that. And if you do it the other way, around, if I did it this way, if I said 90 minus x is equal to twice x, the only difference is you'll get this one 30 and this one 60, because you will go 90 is equal, add x is equal to 3x, so x now is 30. So there's still going to be 30 and 60. If x is 30, then 90 minus x is 60. So either way you did it. Again, you could have done it in two variables. It makes it a little bit more complicated because you have to use simultaneous equations. Let me actually show you it that way. All right, when you use two variables, define one of the angles as the smaller, the other as the larger. I happen to say x is the smaller, y is the larger. You could have flipped it, doesn't matter. And it said one angle is twice the other. Well, that makes the larger, that means that here, your two equations are going to be this. One is x plus y is equal to 90. They're complementary, therefore, like the peanuts. Therefore, x plus y is 90. And it said one is twice the other. That means the larger, y, is equal to 2x. Here are my, you're going to see using the bracket, that means solve them simultaneously. You can do it by addition, subtraction, or by substitution. Addition, subtraction, you want to add or subtract the two equations or multiples of the two equations from one another to try to eliminate a variable, eliminate one of the two letters. Or you can use substitution. Take one equation and solve it for one of the letters and plug that value back in the other equation. Well, here I've already got one letter in terms of the other. Y is equal to 2x. I'm going to use the substitution method. I'm going to take this value for y and plug it in the first equation. So you get x plus 2x equals 90. So 3x equals 90. X equals 30. If x is 30, the other angle is twice x, or 60. You still get the same answers. You're just doing it a different way. Whichever way you feel more comfortable with, unless you're absolutely told, solve this using substitution method, using simultaneous equations, you can choose which you want. Unless you're absolutely told to use one method as opposed to the other, use the one which you find easier. And again, personally, I always find it a little bit simpler to use one variable as opposed to two. But again, that's just my preference. Okay, 30 and 60. Next problem was number 9, I believe. All right, number 9. Your first little proof. And again, with a proof, generally you're going to start with a figure. They gave you the figure. You do not have to redraw it on your paper. It's right there given to you here, and they told you MRPO. And so you start off with a figure. You then have to have a given statement. The given statement is information that they're telling you is true. In order to do a proof, you have to start somewhere. And what you always will start with is your given information. They're telling you this is true about this figure. And what they told you is MRO is the complement of PRO. MRO is the complement of PRO. And I am going to use numbers to make this a little bit easier. Angle 1 is the complement of angle 2. They're giving you that fact. And they said, prove that angle MRP is a right angle. All right, in order to prove an angle is a right angle, I have to prove that its measure is 90 degrees. That's what the definition of a right angle was. All right, now I'm ready to do my 2-column proof. Generally, you'll do it right underneath. I don't have room. Always start with what you know is true, given. And again, I said, I will just accept this, given. You don't need to rewrite it all. And this will save you a lot of time, especially when we do longer proofs that have a lot of given information. Just say given. That means this is now entered into the problem, the proof. All right, now, in a good deductive proof, you have to look at at a step, and from that step, is there anything else that I can deduce? And the answer is yes. You're told they're complements, and what do I know the definition of complements are? Two angles that add up to 90. So angle 1 plus angle 2 equals 90. That's the definition of complementary angles. The definition of complementary angles was two angles that add up to 90. Well, if 1 plus 2 equals 90, what does that tell me about angle MRP? Angle MRP is a right angle. By the definition of a right angle. The definition of a right angle was any angle that adds up to 90, or whose measure is 90. We just proved in step 2 that its measure is 90. 1 plus 2 is this angle, angle MRP. It adds up to 90, therefore it has to be a right angle. That is a good deductive proof, short one, but that is a good deductive proof, 2-column proof. Left column, statements, right column, the reasons for making that statement. The reasons will always be definitions, theorems, postulates, etc. So there is your first deductive proof. Next problem was number 18. Problem number 18 said, if you're totally flummoxed by proofs, don't fret. The more that we do of these, the better you'll get at them. Number 18 said the larger of two supplementary angles exceeds 7 times the smaller by 4 degrees. Find the measure of the larger angle. All right, a lot of info in here, a lot of words. The larger of two supplementary angles, all right, so I know they're supplements, I know that they have to add up to 180, exceeds. The word exceeds means is larger than. 7 times, times means product. So I've got a bunch in here. I've got addition, I've got multiplication. And it said it exceeds 7 times the smaller by 4. Again, this problem can be done in 2 variables. It can be done in 1 variable. I'm going to do it in 1 variable. The 2 angles are x and 180 minus x. I know that because they're supplementary angles. Now, in this case, you can name either angle, the smaller angle or the larger angle. I'm going to say let this be the larger, so x is the smaller. If you want, you could do it the other way. I picked this way because it's going to make the problem a little bit easier. It said the larger of 2 supplementary angles is 4 bigger than 7 times the smaller. This, the larger, is 4 more than 7 times the smaller. Well, 7 times the smaller is 7x. And this is 4 more than 7 times the smaller. That's why I picked the x to be the smaller and this to be the larger. If you flip these, you're just going to have a bigger multiplication. More margin for error. Always try and pick it so that when you actually have to do the problem out, there is a less chance of making a multiplication or subtraction error or an addition error. So there's my equation. Now just do it out. You get 180 minus x, excuse me. Let's add x to both sides. You get 180 is equal to 7x plus x, which is 8x, plus 4. So 8x is equal to 176. Therefore, x divide by 8 and you get 22. X is 22. Now again, what I've got here is absolutely correct. However, be careful that you don't stop one step short. They didn't just want you to solve for x, they wanted you to solve for the larger angle. Well, x is the smaller, therefore the larger. 180 minus x. 180 minus 22 is 158. So the answer that they actually wanted was 158. They wanted the larger angle. Okay, let me just show you the setup for those of you that like two equations and two variables. Hopefully everybody understands this. Here's the setup if you did it in two. Let x equal the larger, or excuse me, the smaller, and y equal the larger. I know that x plus y is equal to 180. There's supplements. And it said the larger y is equal to 4 more than 7 times the smaller. So there's your system if you did it in two variables. And again, in this particular case, this one's just as easy to do using substitution since I've already got the second equation solved for y in terms of x. You would take this value and substitute it there and then do the problem out. You'll get the same two answers. You'll get x is 22, y is 158. Y is the larger, that's the angle that they actually asked you to solve for. Problem number 18. And then the last problem, I believe, is 21. Problem number 21, another numerical. The supplement of an angle is 4 times the complement of the angle. Find the measure of the complement. Again, this is one where you may stop one step short. Hopefully you didn't, or you won't. All right? It said that the supplement of an angle, so let's just call x the angle. That would make 90 minus x the complement of the angle, and 180 minus x the supplement of the angle. So I'm doing this in one variable. Let x be the angle. The complement of that angle, the complement of x is 90 minus x. Common error. People will say x minus 90, x minus 180. Now, if two angles add up to 90 and one of them is x, the other is 90 minus x. If two angles are supplements, that means they add up to 180. So if one of them is x, the supplement is 180 minus x. Very common error. People flip those around. It said the supplement of the angle, the supplement, 180 minus x, is equal to 4 times the complement. Now be careful, put it in parentheses. It's 4 times the whole quantity, 90 minus x. There's your equation in one variable. Again, you could have done this in two variables. It makes it much more complicated, I think. This is a pretty straightforward problem now. It's just algebra. 180 minus x is equal to 4 times 90, 360 minus 4x. So let's bring the x's over to the left. Add 4x to both sides. You get 180 minus x plus 4x is plus 3x equals 360. Subtract, you get 3x is equal to 180. Divide by 3 and you get x is 60. Don't stop there. That's the angle. They asked for the complement. So the answer that they're actually looking for is that, 30. You find the angle, and then they asked you what is the complement. Find the measure of the complement. So there's your final answer, 30. Okay? Again, if you were totally confused by anything I just talked about, and flipping back and looking at it again didn't help, please call me or email me. I'll be happy to answer any questions you might have. And again, if you have forgotten, I am reachable at 240-701-4470 or rollydean2000 at gmail.com. Okay? Alrighty. Moving on, you're going to get another theorem. And I am going to give you shorthand versions. We're going to actually get 4 theorems, but I'm going to combine them, and we're going to end up with 2. The first one says this. Complements of the same angle or congruent angles are congruent, and we're going to just call this the complement theorem. That's all you need to ever write if you use this. Complements of the same angle or congruent angles, that means if they're complements of 2 angles that are congruent, then they themselves have to be congruent. Here's a case of this. Here, angle X is the complement of angle Y. Angle Z is the complement of the same angle Y. Therefore, and you're going to see this little thing. If you see a little triangle with the 3 dots, that means therefore, I can say angle X and Z have to be congruent by complement theorem. Plug in numbers. 30 is the complement of 60. 30 is also, X is the complement of 60. Z is the complement of 60. That means X and Z both have to be 30. They're congruent. Complements of the same angle or congruent angles have to be congruent also. Complement theorem. If you just substitute in the word supplement, you get the same exact thing. Supplements of the same angle or congruent angles are congruent, and this will be abbreviated just supplement theorem. Complement and supplement theorem. Complements of the same angle or congruent angles are congruent. Supplements of the same angle or congruent angles are congruent. Supplement theorem and complement theorem. Okay. Look on page. If you look on page 80, let's do a simple a proof. Look at problem number 11 on page 80. Sorry. Let me get some water. Son of a gun. Sorry. Okay. All good. Okay. Problem number 11. I'm going to draw it up. Again, if you were doing this problem, you don't need to read. Okay. Sorry. If you were doing this problem, you do not need to redraw this. Since the problem is already drawn out for you, it's got the figure. And in this problem, what you start with is something that looks like this. Problem number 11. It said, given that f is They told you angle F is a complement of angle FGJ. I'm going to call it angle 1. It's easier to talk about angle 1. And they told you that angle H is the complement of angle FGJ. GJ bisects angle FGH. So this bisects this angle. So I'm going to call that angle 2. Again, if you're doing this problem and you use numbers, that's fine. It makes it easier. When I talk about angle 1 and 2, that's a whole lot easier than talking about FGJ and HG. You have to look it up. So it's much simpler when you have multiple angles at the same vertex to use numbers. All right, now, they wanted you to prove in problem number 11 that angle F and H are congruent. So I want you to prove these two angles are congruent with this given information. Now here's a perfect case where I said I will accept this. 1. Just write that, given. This is now entered into the proof. You don't need to rewrite it all. All right, now, statement 2. Given these two statements, F and H are complementary to the same angle. That makes angle F congruent to angle H by the complement theorem. That's the reason. We just said, or we just proved the complement and supplement theorem. Complements of the same angle or congruent angles, that's angle H. Complements of the same angle or congruent angles are congruent. F and H are complements of the same angle, angle 1. Therefore, they are congruent. All right. Now, I also know that, well, actually, we're done. Wait a minute. I don't think that number 11. Oh, I'm sorry. I rewrote. I take this back. I gave you the wrong given. It said that angle H is the complement of HGJ. So angle F is a complement of 1. Angle H is the complement of 2. Okay, so that adds a step or 2. From the given information, GJ bisects this angle FGH, so that tells me angle 1 is congruent to angle 2. That's the definition of angle bisector. Angle bisect. An angle is bisected if it's cut into two congruent pieces. Therefore, 1 and 2 are congruent. Now I can make my final statement. Since 1 and 2 are the same, and F and H are complements of congruent angles, I can say angle F is congruent to angle H, now I can say by complement theorem. Complements of the same angle or congruent angles are congruent. Complement theorem. Supplement theorem, supplements of the same angle or congruent angles are congruent. Okay, that's how you use those. Sorry for misleading you there at first. Holy mackerel, what's going on here? Okay. In algebra, you had the four axioms: addition, subtraction, multiplication, and division axiom, that said if you have an equation, you can add the same thing to both sides, it won't change it. You can subtract the same thing from both sides of an equation, it won't affect it. You can multiply both sides by the same thing or divide both sides by the same thing, it won't change the equation, it'll still be a true statement. Well, the same is going to be true geometrically when we talk about angles and we talk about line segments. The addition and subtraction property will always work. You can add line segments together, or you can add pieces of line segments together, and their sums will then also be equal. In other words, if I have a line segment like this, A, B, C, and D. If I gave you this figure and I told you AB is congruent to CD, if this little piece is congruent to that little piece, well, BC, anything is congruent to itself. That's called the identity property. Anything is equal to itself. I can always say, so I could say BC is equal to itself. Well, now let's look at this segment and that segment, from A to C and from B to D. Since these little pieces are congruent and BC is equal to itself, if I add the measure BC to AB, I get AC. If I add the measure BC to CD, I get BD. Therefore, I can say, since these two little pieces are equal, and I'm just adding the same piece to both, I could say that AC is congruent to BD, and the reason I can say that is the addition property. You can add line segments together and get bigger line segments congruent. It will also work with angles. Holy moly, this is not good today. All right, if I had if I gave you a figure that looked like this, and I told you this angle, angle ABC, angle 1, is congruent to DBC, or excuse me, DBE. By addition property, I could say that this angle, angle ABD, is congruent to that angle because I have simply taken these two little pieces and added this bigger third angle in the middle here, which is congruent to itself. Therefore, angle ABD is congruent to angle EBC by addition property. The opposite is also true. Subtraction. Call that 3. If I started with the big angle, angle AB, if I told you angle ABD is congruent to angle CBE, I know that angle 3 equals itself, identity property, and then I could say that angle 1 is congruent to angle 2 by subtraction. If you take the big angle and take 3 away from it, you take this big angle and take 3 away from it, what's left are 1 and 2, and therefore they have to be congruent also by subtraction property. So you can add angles together, you can subtract pieces of angles from bigger angles, and you will get their sums or differences congruent also by either addition or subtraction property. And likewise, if we started off by saying segment AB is congruent to CD, and I told you E and F are midpoints, does that make all of these little pieces congruent? And the answer is yes. Since E and F are midpoints, that means this is congruent to that, and it means this is congruent to that. But since the big pieces were congruent, that means all of the halves have to be congruent. This is true by either multiplication or division. If I multiply by a half, that's the same as saying dividing by 2. So I could say AE, EB, CF, and FD are all congruent by either multiplication by 1/2, since you're told they're midpoints, or division by 2. When you multiply by a half, it's the same as dividing by 2. So anytime you start with big segments being congruent, you can get pieces congruent by multiplication or division. So all 4 of those axioms we talked about, addition, subtraction, multiplication, and division, are true with respect to angles and line segments. You can always add line segments together. You can always subtract line segments from one another. Same with angles. You can add angles together or subtract from one another. And in terms of multiplication and division, when you start with big things, you can split them in half, and then all the if wholes are equal, halves are equal. It's another way of thinking about it. If I have 2 whole line segments, AB and CD congruent, and I cut each of them in half, then all of these halves have to be congruent, and I would accept either multiplication or division for that one. You multiply by a half, or you divide by 2. And let me just show you a problem or two on page 92. Now again, you're going to start seeing problems where you're going to be given figures. Everything's going to be labeled. They're going to give you information. And then you're going to either see the word prove or conclusion. They are synonymous. If you're asked to prove something, it is a 2-column deductive proof. If you're asked for conclusion, the word conclusion is synonymous. It means exactly the same as prove. But there is another option that you're going to see sometimes where they are going to ask you to, they'll give you a figure, it'll be labeled, they will have given information, but then you'll see the word find. The word find means it is not NOT, it is not a proof, If you see the word find, it is numerical. They want you to actually do it out numerically and find the number. You don't have to do it as a deductive proof. You only need to do a deductive proof when you see the word prove or conclusion. And the problems that you're going to get for tonight are that way. On page 92, you're going to have a couple of problems where they give you all sorts of information, and then one of them says conclusion, and one of them says prove. Those are both two-column deductive proofs. And again, we're early into this. If you're confused by these proofs, please don't worry. We will do more, and hopefully you will get better and better as we do more. And I actually do not want to talk about anything else. And I will hopefully answer any questions that you might have about this stuff on Friday. So, for Friday, page 79, 148. Stop already. 10 and 19. Page 86. Number 4, 6, and 10. And page 92. Number 2, 12, and 13. Okie dokie. So again, please, if you are struggling with something, please feel free to call or email me, and I will get back to you as soon as I can. And I look forward to seeing you all on Friday. Have a good week. Thank you.